Hello, in this video I'm just going to do a few examples showing you how to use trigonometry to solve for the missing sides of a right triangle and how it works with special right triangles. So, if we look at example 3 here, we want x and y. They gave us 25 degrees, that's going to be our theta, that's going to be our focus angle. Although you could do 90 minus 25 and use the other angle if you wanted. And so we need to solve for x or y. Let's solve for x first. So I'm going to say to myself, all right, what's the opposite, what's the adjacent, and what is the hypotenuse? So the hypotenuse doesn't change. It's right down here, right across from the right angle. And then if I'm focused on the theta here, the opposite is going to be x, and the adjacent is going to be 18, right? Because 18 is right next to theta, and it's not the hypotenuse. So to set this up, how am I going to use? I need to use opposite and adjacent. So I look at my trigonometric ratios, and I say to myself, which one uses opposite and adjacent? And that's going to be tangent, because tangent of theta is equal to opposite over adjacent. So tangent of 25 degrees is equal to x over 18. All right, now essentially here I need to get x by itself, so I just do 18. I multiply both sides by 18, right? And I use a calculator. So 18 times tan of 25 degrees is going to be x. So I'll switch to the calculator, and I do 18 times tan 25. Ooh, not 225. 25, it's in degrees, end parentheses, equals, and I get 8.39 after rounding, right? So x is about 8.39 is equal to x. All right, from here I would, suggest using the Pythagorean theorem if you wanted for y. So let's see how that looks. So I have 18 squared, change colors here, 18 squared plus x squared is equal to the hypotenuse y squared. 18 squared plus 8.39 squared is equal to y squared. Right, go back to the calculator. Right, 18 squared plus 8.39 squared is equal to, right, 394.39. 394.39. So 394.39 is equal to y squared. Don't forget, you got to take the square root of both sides now to get y. We'll have to go right back to the calculator. So I'm going to do the square root of 394.39. And that's going to be about 19.86. 19.86. All right, and we can just very quickly verify that answer. Let's use a different trigonometric ratio to solve for y instead of using the Pythagorean theorem. So this is just an option. You don't have to do this necessarily. So what's going to involve y and which is hypotenuse? What involves hypotenuse and adjacent? And that's cosine. So I know that cosine of 25 degrees is going to be equal to, cosine is adjacent over hypotenuse, so it's going to be equal to 18 over y. All right, so get rid of that middle part. That's kind of confusing to work with. So 18 over y. So this time y is in the denominator, so I have to do sort of two math moves to solve for y. First, I'm going to multiply both sides by y, right, to get y out of the denominator. And I have y times cosine of 25 degrees is equal to 18. So cosine 25 degrees is a coefficient of y now. It's just a number. You could put it in a calculator now if you wanted to. I'm going to divide by cosine of 25 degrees on both sides to get y by itself, and now y is alone, and I have y is equal to 18 over cosine of 25 degrees, and we'll go to the calculator and make sure that that matches up as well. Right, so 18 divided by cosine of 25 degrees, and that's equal to 19.86. So very, very similar numbers. And since we rounded, we're expecting a little bit difference, but definitely getting the same thing. So y is equal to 19.86 after rounding. So I have, there's an answer, and there's a different way to solve for y. All right, so let's look at example 4. Maybe we'll move it over a little bit. Okay. And we have, we're looking for r and p. So let's get maybe r for this one. We'll start with r. So r is the hypotenuse, right? P is opposite, and 15 is adjacent. So I'm going to ask myself, hey, what involves the hypotenuse and the adjacent? All right, well, that's, come over here if I need to, and that's cosine again. So cosine of 70 degrees is equal to, that's adjacent over hypotenuse, so 15 is the adjacent side over r is the hypotenuse, right? Our variables in the denominator again, so we'll have to do the same move as before. We're going to multiply both sides by r, right? And I have r times cosine of 70 degrees, which is just a number, is equal to 15. Going to divide by cosine of 70 degrees so that I can get r by itself and therefore solve for r. So r is equal to 15 over cosine of 70 degrees. I'm going to switch back to the calculator. Right, so 15 divided by, that was cosine of 70 degrees, and that's going to be 43.86 after rounding. So r should be equal to 43.86. All right. And then solve for p really quickly. So p is opposite. So what involves opposite and adjacent? That's tan again. So tangent of 70 degrees is equal to opposite p over adjacent 15. All right, so this one's a little bit easier again. I just multiply both sides by 15. And I now know that p is equal to 15 times tangent of 70 degrees. And let's see if I can bring that calculator up right here. Good, so 15 times tan of 70 degrees. And apparently that's equal to 41.21. So 41.21 is equal to p. All right, so once you get it, the problems, they get easier to solve each time as you practice them. All right, continuing on, now we have special right triangles. So the idea here is you might be asked to solve one of these without a calculator. So you'll notice the 30, the 30, and the 60, and it should hopefully ring a bell to you that this is our special right triangle, which is the 30, 60, 90 right triangle. Now they're all similar, right? No matter how big or small it is, so you have two choices here. You could either do just the pattern by filling in x's, so 30 x, and then the hypotenuse is 2x, and then the long leg is x root 3. Or if you prefer, you will get the same answer. You can use numbers. So if my 30 is up here and my 60 is down here, you could put 8 here. This would be twice 8 or 16, and this would be 8 root 3. All right, so let's go ahead and solve these real fast. I'm going to be using this one on the left to do it. So sine of 30 degrees. Well, sine, and again, you don't have to write this each time. I'm just putting it there as a reminder. It's a nice, easy thing to write, and then you can look back at it. So sine of 30 degrees, that's opposite over hypotenuse. 30 is my angle. Opposite is x, so that's equal to x. And hypotenuse, well, that's always the same. That's 2x. So x over 2x, so that's just equal to 1 over 2. Okay? Then cosine of 30 degrees. Again, 30 is my key here, right? So 30 is right here, but this time it's adjacent over hypotenuse, right? So this time it's x root 3 over 2x. So, or in this case, the x's will go away, right? So you just have root 3 over 2. And then for tangent, I used 60 degrees, tangent of 60 degrees. So for this, I'm actually looking down here at 60. Erase these old ones. And I'm going to do opposite over adjacent. So x root 3 over x. And that's just going to be root 3, which is nice. Now, not to skimp out on the harder version of this, so let's also very quickly, we'll do tan of 30 degrees as well. So now I'm looking at 30 degrees. 30 degrees right here for tan. And this one is actually going to be opposite over adjacent. This one's going to be x over x root 3. So x over x root 3. And this one is complicated because now you're left with 1 over root 3, and we can't leave that in the denominator. So to simplify this, we just multiply by root 3 over root 3, right? And that gives us root 3 up top, and on the bottom, root 3 times root 3 is just 3. So tan of 30 degrees is root 3 over 3. And that's how you do it with the special right triangles. And let's just take a look at the 45, 45, 90 triangle for this last example to finish this video. So the 45, 45, 90 triangle is isosceles. Again, you can use the pattern, x, x, and x root 2, or you can use you can fill it in with numbers if you want, 2, 2, 2 root 2, although that might be, maybe not 2, because you don't want to confuse yourself, maybe 3, 3, 3 root 2, something like this. All right, so these are the 45 degree angles, and again, it doesn't matter which one you use. So sine of 45 degrees, well, this time it's a little bit harder to mess up because they're both 45 degrees, right? Sine is opposite over hypotenuse, so it's x over x root 2, right? So it's going to be 1 over root 2, which we simplify by multiplying the top and the bottom by root 2, and we get root 2 over 2. Cosine should match, right? Because it didn't matter which way you went for sine. Let's use a different color. Red, sure. So red right there. We'll use that one, and it's just x over x root 2 for adjacent over hypotenuse. So x over x root 2, and you get 1 over root 2 times root 2 over root 2 to simplify, and you're left with root 2 over 2. Finally, we have tan of 45 degrees, which is just going to be x over x, because opposite and adjacent are both legs. They're going to match, they're the same length, so you get 1. All right, and there's some examples, and I hope they were helpful. Thank you.